Now we'll look at vertical asymptotes. Vertical asymptotes occur on our graph when the output shoots up to either positive infinity or down to negative infinity, and it does not cross this line. So that line right there is a vertical asymptote. To figure out vertical asymptotes, what we want to do is we want to look at the denominator now. The factors of the denominator tell you where a vertical asymptote is located. This is because when the denominator is 0, the function blows up or is undefined, which produces a vertical asymptote. And the reason we either see positive infinity or negative infinity is because as we approach this value that gives us a vertical asymptote, one of our factors is going to get really small. It's going to be 1/10, 1/100th, 1/1000th, which makes the whole denominator very small. Well, when we divide by an extraordinarily small number, the entire fraction gets extraordinarily large. And that's what makes us either go up to positive infinity or down to negative infinity. Either way we're going to infinity, the sign just depends on the signs of our factors in the function. We do see that multiplicity matters. If it's an even multiplicity, then our function, if we have a vertical asymptote, an even multiplicity means that the function is going to go in the direction of the same infinity. So here, both sides are going up to positive infinity. It could also be that they'll both go down to negative infinity, and either way they're going towards the same infinity. For an odd multiplicity, we see that on either side of the vertical asymptote we approach opposite infinities. So one will go to negative infinity, the other side goes to positive infinity. This is even, this is odd. Let's look at our example. Again, we're focusing on the denominator. Here we have factors of x minus 2. We have a vertical asymptote then at x equals positive 2. We have another factor of x plus 11. We have another vertical asymptote at x equals negative 11. At x equals 2, we will have the same infinity because we have an even multiplicity. At x equals negative 11, we'll go to opposite infinities because we have an odd multiplicity. Let's put these on our graph above. We have vertical asymptotes at x equals positive 2. This is same infinity. And another one at x equals negative 11. And that is opposite infinities. So far, so good. That takes care of vertical asymptotes, your second part of rational functions. If this makes sense, then go on to the part about end behavior. This is probably the most difficult part for students to understand, so really make sure that both roots, which have to deal with the numerator, and vertical asymptotes, which have to deal with the denominator, make sense to you. If you're ready, go on to end behavior.